Right, Steve, I think we'll start. Right, good evening, good morning, wherever it is that you may be dialing in from within the world. Thank you for doing so. This is our, third monthly presentation that we've been doing by SoPHE and specifically SoPHE Northern region. For those of you who don't know me, I'm Malcolm Atherton. I'm actually the SoPHE Northern Secretary for the region. We would normally be having CPDs put on locally in Manchester, but due to these current climate and circumstances, we've been doing this online on a monthly basis. And for your information, we shall be continuing doing so for next month and up to and including March next year. And if we have to continue doing it beyond that, then so be it. I hope we can put on a programme to which you all find of interest. So for those of you who don't know, SoPHE, SoPHE, which stands for Society of Public Health Engineers, an affiliated society to CIBSE, along with 4 or 5 other societies, and we specialise in public health and everything associated with public health. Altogether, we have in excess of 1,200 individual members worldwide, and we have what's called industrial associates, which is currently we're talking about 77 IA members. These are manufacturers, be they water treatment manufacturers, pipe manufacturers, whatever, anything and everything to do with public. I think we're doing very well on that front. All I would ask, please, if you do come online, can you please ensure that you are muted so we can hear what Stephen Royle, our presenter, is talking about? And correct me if I'm wrong, Steve, if anybody wants to ask a question, for them to put it in the chat box.
Yeah, I've opened the chat box, so if you type something in, it will pop up there. If there is anyone who wants to ask any questions, we'll have a quick Q&A after the presentation's finished.
Great stuff. Okay, well, without further ado, I will hand the virtual floor over to you, Steve. Thanks very much.
Thank you, Malcolm, and thank you very much for everybody attending. I'm looking at the numbers here, and it's very impressive. Over 70 of you have tuned in this afternoon to see me, or in the morning, wherever you are, and I've recognised some of the names that have popped up there. I hope you can all see the screen that I've shared. So I'm going to give you a presentation on the Evac Vacuum Drainage System. Don't know if you guys had come across this before, but I've been given the opportunity by Malcolm to present this to you. I know not all of you are based in the north, and it was very important for me to try to talk to the people that are in that region. One, so that we get projects beyond London and beyond the M25, and secondly, I understand that, you know, Manchester is about to undergo some financial revolution in some respects. They're building HS2, and they want something decent at the other end of it. Not suggesting that Manchester isn't at the moment, but it just means that there will be, from what I hear, it's going to become a very busy region in the coming years. So it's good to talk to you guys and let you know all about my system. So who are Evac and what are we? Evac are basically a Finnish company, and I don't want to go too much into the company and what they are as opposed to or who they are, but I'd just like to show this quick slide so you can see that it is a rather large company. It's not a couple of guys in a shed putting a system together. Been going now in its present guise since 1975, and in that time has grown into a 150 million euro per year company. So you can see it's quite a big organisation. And fitted now, or our system's been fitted into over 2,000 buildings throughout the world, and it can be any variety of building. We don't have to say it's got to be a particular, it's got to be a hotel, it's got to be an office. It's any building is suitable for vacuum drainage. So let me tell you what it is. It is a vacuum drainage system, an alternative method of draining, as opposed to what the type of things that you're used to. And as for you guys as designers, it can offer you many benefits. One is it's flexible. You are able to come out of evac items and lift up to high level, transport waste at high level. And secondly, something I'll go into a little bit more detail in a while, it has great water savings. And the pipes that we use for vacuum drainage are significantly smaller than conventional pipes. So it means that coordination in risers and at high level becomes a little easier when you're using a pipe half the size than what you're expecting. So vacuum drainage, like I said, gives you a way of being able to drain a building without having to rely on traditional gravity or pumps. It gives you that flexibility to be able to position sanitary items wherever you want, which makes remodeling and future-proofing the system very, very easy. And as you said there, Evac aren't a new fly-by-night company. This system has been developed and honed for the building industry over the past 50 years. So you can defy the traditional methods and the traditional rules by using a vacuum drainage system. And if you look at the graphic there, you can see two ways of draining a building. The building on the right there, the gravity solution, is something that you're all very familiar with, having to position sanitary items close to the fixed riser positions. And if you look at the one on the left-hand side, there are no traditional stacks. You can rise up when you come out of the Evac toilets and interface units, which gives you that total design freedom. And the system is all designed around the European standard 12109. So vacuum drainage, why would you use it? So it's sort of really become a get me out of a problem product. And I generally say to people, I can't use gravity drainage because. Now, why can't you use gravity drainage? Well, it can be a number of reasons. It could be the floor's reinforced and you're not allowed to excavate. Program, there's a limited program and you don't have the time to be able to go down and excavate. Something that's very common now, the building's leased and landlords won't let you excavate. They want to rent you a building, but they want it back in the condition when you finish, where they give it to you. So they can't be having you dig up the floors. Or you might only be working in a section of the building and the high level services on the floor might not be permitted. So for example, for that would be you're fitting out something and retail. There's a retail unit below you and the retail unit doesn't want you coming down into their domain. So vacuum systems will allow you to be able to design around that. It could be something to do with the foundations that won't let you excavate. High water tables. We've done buildings that have been close to riverbanks. And not necessarily right on a riverbank, but something on the south bank of the Thames, where there can be a very high water table within to 50 to 100 meters from the actual river. You can see there's lots of different reasons, right down to you might just want to save water, you might want to not to use a network of pumps. So you can see plenty of reasons why you can't use gravity. So how does this thing work? Well, you have a series of pipes that connect each of the appliances back to a collection tank. And this pipe is under a negative pressure. Now, you probably all know about negative pressure, you all know about vacuum, but just to give you an understanding, when we talk about positive pressure, you'll often hear people talk about in, say, the pressure in water pipes, that this has been set at 3 bar, this has been set at 5 bar. With negative pressure or vacuum, -1 bar is as far as it goes. That is absolute vacuum. It's not an infinite scale like positive pressure is. So you have these pipes that are under a negative pressure. So what that means is if you get a leak in a vacuum pipe, you actually get air leak in and not water leak out. And because we're working under these high pressures of negative pressure, it means that the water will run through the pipework at speeds of around about 10 meters per second or 20 miles an hour. And that also, because of that force, gives you the ability to lift waste up into ceilings to around about 6 meters in height. And because the pipes are taken up into the ceiling voids, there's all your requirement for expensive underground drainage is eliminated. And like we spoke about in the reasons earlier, that can have a big time-saving benefits for you. And our high-level pipework is only installed on a very gradual fall. You can see there, just 1 in 200. So this makes pipe falls very, very shallow, which means you can have very long runs of pipes and keep them in very tight compartments. If you imagine you had a pipe run that was, say, 100 meters long, and you were running at a 1 in 40 or 1 in 60, the pipe drop would be, significant. But 1 in 200, it's very, very shallow. Somebody just asked a question: is it noisy? To give you an example of how noisy it isn't, we have a lot of projects in hotels. And the quietest places in the world that I've ever been to are hotel corridors. You've got nice soft furnishings, you've got no windows, there's no ambient noise. And what you've got is the vacuum pipes running above your head, only protected by, and when I say protected, I mean acoustically protected by the ceiling. We do not lag these pipes. You don't tend to hear anything that is traveling through these pipes in no more way than you would if you put your ear against a stack and you can hear water dribbling through this. In the same way, if you put your ear to it, you'll hear a whoosh as it goes past. But it's not something that you walk along the corridor and you think, whoa, what was that? Someone's just emptied a bath or flushed a toilet. So it's pretty quiet. Someone's asked a question: is there a size limitation to this system? There isn't a size limitation. The system is sized accordingly, and that's a service that we'll offer that perhaps I'll talk about a little bit further into the presentation. So when a vacuum appliance discharges, a discharge valve opens, and this is a sort of discharge valve that you see in the back of our toilet. When I say you'd see it in the back of the toilet, you'd see it if you were looking in the back of the toilet. You wouldn't see it if you were using the toilet. And when the valve opens, and the valve opens by the user pushing the button, atmospheric air causes the air to flow into the pipework. Now, the layman terms for that is, if you imagine you had a room and you put the room under vacuum, okay, you took all the air out of the room, and then if you open the door to that room, what would happen is air would rush in and fill that room. That's the physics of what happens to atmospheric air under a vacuum. Now, if you were standing in front of that door when you opened it, that inrush of air would be so great that you'd be thrown off your feet and thrown into the room. And this is pretty much how a vacuum system works. A vacuum drainage system works. When that valve opens, it isn't the vacuum in the pipework that's actually sucking the waste out of the pan. It's when we flush a toilet, we get between 60 and 80 litres of air is pulled into the pan. And as that 60 to 80 litres of air enters the bowl, if there's waste, if there's paper, if there's anything in there, that air will simply push that through the mouth of the pan, up the high level pipework, and then back towards the vacuum collection unit where the vacuum's generated. Hence the reason why we're able to lift to high level and it flows at such a high velocity, because the powerful vacuum generates this air pull. And to give you one of the two examples of the ferocity of the vacuum, when we have one of our projects at St Pancras Station, and I will say that toilets at railway stations are probably the most abused toilets in the world, and our guys have to go and open the tanks there a couple of times a year to do the maintenance. And we're often finding inside the tank T-shirts, towels, we've had mobile phones, we've had passports, things that will actually get poured through a vacuum toilet, poured through a very small pipe, and work in the case of St Pancras, travel the 250 meters back to the plants, back to the collection tank for some poor soul to have to fish it out during our monthly maintenance. So you can see it is a really powerful vacuum. So once the water has passed through the pipework, it's then making its way back down to the collection unit. The collection unit is always positioned on the lowest point of the system to what we're draining, not necessarily next to the sewer, because we have the ability to pump out to wherever the sewer is. And what we can see now is an animation of how the system works. So what we're going to see in a moment is what we've got here is like an X-ray building, and the user is going to flush the toilet. Here comes our wastewater rising to high level, and I just want to pause that there. So what you can see there is the slug of water has risen to high level. It's running through the pipework that's only at a 1 in 200 full. And we then come to what we call a transport pocket. And the transport pocket serves for a couple of reasons. A few moments ago, I said that we could get very long runs, a very small fall. Well, every 30 meters, we will install what we call a transport pocket. It's just made up of pipe and fittings and would be very similar to, say, a running trap in the pipework. But what happens is when the water has lifted up the pipework, it's as a nice tight slug of water, and as it gets onto the high-level pipework, the water begins to flatten out and elongate, and our 60 to 80 litres of air that's been pulled into the pan to push it through the pipework will flow past it and leave it behind. The 1 in 200 fall keeps the slug moving, and it may settle down, if it's lost all its inertia, into the bottom of a pocket and reform as a slug of water. Then when the next burst of air comes along, it will crash into the water that's sitting and waiting there and transport it on to the next transport pocket, hence the name transport pocket. The second reason for the pocket is that if we've lifted up, say, 3 meters off the back of our toilet and we're on our 1 in 200 fall, by the time we've travelled at 30 meters along to get to our pocket, we may be at 2.8. As we step back out the pocket, we then step back up to 3 meters, and we'll go onto our next pocket and step back up, and onto our next pocket and step back up. So it gives me the example of how I can get very, very long runs in my pipe work. And the question just popped up, is there a maximum horizontal length? There is a maximum horizontal length, because the maximum lift we can have is 6 meters. Now, I just used in my example there, we lift up 3.5 meters, or 3 meters, I said in my example there. As we come out of our transport pocket, we might pop up 250. Let's just say 250 for the ease of maths. So now my total lift is 3.25 meters. And then when I get to my next transport pocket, I'll lift up another 250 mil. So I'm now at 3.5 meters, and I keep going and keep going. Once I've reached 6 meters, I've then reached the maximum. Now, if I came out that toilet and I dropped down to low level and didn't have a lift, it then means that my maximum lift or my maximum run can be much longer. So I'll just continue to run the animation. You see the slug water pass through the transport pocket, and it's heading down to the lowest point of the system. And to reinforce the last point I just made, you can see this toilet here, it's what downward system. There is no rise. It's coming out of the back of the toilet, dropping down to high level. You can see here that we use the transport actually to stimulate other obstacles. So when I the example of vacuum systems. Sorry, can everyone hear me? Can someone just put in the? Yeah. Okay, sorry. Did I
Steve,
go?
it's going in and out at the moment, Steve. To be honest, sometimes it's good. It's when you're showing your graphic and the illustrations. That's when it seems to go a bit funny.
Right. Okay. Okay. I will also make sure the next time I run a graphic, I keep stum. But what I was just what I was saying there, in case is no one heard, is that you saw on the second part of the example there that the toilet came out of the back of the pan and dropped down and ran at high level on the floor below. And that means that you don't have to come up and rise up to high level. You can drop down the floor below, and we can be using the transport pockets there to step around other obstacles. So that then goes to reinforce the story I said about the system being flexible. We're running our vacuum pipe along, we come to a piece of ductwork, we can simply duck underneath it and step back up the other side and continue on our floor. I'm just going to go to some of the questions that we've got here. Is the system not in use for a long time? Will it lead to a blockage? Not particularly, no. I mean, we haven't really had any systems that haven't been used for long times. What you do find is that well, we're finding that we've got some systems that aren't running for long times at the moment, where we've got buildings that have been shut down through COVID, but we've got maintenance guys in there, and they're going in, and from a Legionella point of view, they're running taps anyway, and because they're running taps, they're using the drainage system. So I haven't had a system that's sat dormant for long enough for anybody to come back and tell me if that's is a problem. Is it safe to say that the general rule of thumb, one in 100 slope is a myth? 1 in 200, in fact, is our minimum that we can run at. So 5 mil in a metre is how we set our pipe work up. We can go more than that if we want to, but that's the minimum we need to achieve. Any other questions? No, for the moment. Okay, I'll carry on. So the vacuum toilet. I think there was a question. I think it's popped off. Someone asked me about the vacuum toilet and the noise, and if they were similar to what you see in the transport industry. And the first thing is, I'm always keen to say that the toilets that we use in buildings aren't like what we use in the transport industry. When you see, well, you've all used toilets on planes and trains, and you get a stainless steel or a Teflon looking sort of contraption that goes with a bit of a pop when you flush the toilet. The building industry just wouldn't stand for that type of system. So you can see the toilets are white porcelain toilets, look and feel like a normal toilet. All of the mechanism is concealed within the bowl itself. So you take the bowl off the wall and there's the mechanical parts, but it's all purely pneumatically controlled. There are no electrical connections on vacuum toilets. There we can see there's an X-ray view of the toilet. You can see the mechanism sitting inside of the bowl, which means it's very easy from a service point of view. You can just undo 2 nylon nuts, the bowl slides off the wall, and then all the mechanical parts are accessible. But from a user point of view, it's unlikely that they will ever tend to know that it's a difference between a conventional toilet and a vacuum toilet. The noise levels, someone's asked there, the noise level of a vacuum toilet as opposed to a gravity toilet actually are very similar. I have a graph, I don't have it on this particular PowerPoint, but it's only about 1 or 2 dB louder, a vacuum toilet, than a gravity toilet. The difference being a vacuum toilet that flushes all over in about 4 seconds and then it's finished. And because we have no cistern to a vacuum toilet, the toilet is ready to flush again straight away. Whereas with a gravity toilet, the actual peak, which is that first part of the flush where the water crashes into the bowl, may be 1 or 2 dB quieter, but it goes on for a lot longer. And then if you've got a cistern filling, like I timed the one downstairs in our staff toilets here, and I think it took 101 seconds for it to stop the cistern filling and making a noise. So you can see that there's a bit of an offset there, just 4 seconds for the flush. Someone's asked there, the selector and the sanitary ware limited. I'm going to come back to that one. I've got a slide in a moment on that. Is there a premium for a vacuum toilet? Good question. how much does a gravity toilet cost? Because if you go in and into B&Q, you could probably pick up a toilet for £100. Yet you go into somebody like CP Hearts, who've got showrooms in London. I know they've got a showroom in Manchester. You can pay over £1,000 for a Philips Stark toilet there. So it's a bit of a sort of a loaded question when it comes to talking about values. Yeah, someone's just asked about the flush volume there. I've got some sort of dB ratings which I can actually share with them later. No, well, the water supply, there's no system, there's no flush valves to comply with water regs. The toilet has to be fitted to a Cat 5 supply. At this stage, Cat 4 double check valves doesn't pass through the water authorities. But a Cat 5 will allow you to fit a vacuum toilet. And if we have a little look inside the toilet, we can see one of the reasons why. Underneath the rim of the bowl there, we've got what we call the flush ring. And the difference between a vacuum toilet and a conventional toilet, if you've got a bucket of water and poured it into a conventional toilet, providing it's not blocked, it would just pass through. Because the vacuum toilet has a closed plug, the discharge valve is in the closed position. If you filled the toilet up or you pour water into it, it would fill the bowl up like filling a bath. And what the water authorities state is that the flush ring could become submerged, and then there is a chance of backflow. Now, Evac actually fit in several safety devices. There's an overflow in the bowl that would prevent that happening. There are mechanical devices to stop backflow pressure. So the chances are 1,000,000 to 1. But as one of the water authority guys said to me, there's still a chance. So to overcome that, the Cat 5 supply gets over all sorts of issues. And if it comes to RAS approval, you ensure that the booster, Cat 5 booster set that you're using is RAS approved, and then that passes everything through. Now, back at the beginning, I said that the Evac system is environmentally friendly. And the reason for that is that vacuum toilets only use 1.2 litres of water per flush. And because we're using 1.2 litres of water per flush, people might turn around and say, well, that's not enough water. You know, you can't clean a bowl. You need 3 litres, you need 4.5, or whatever conventional toilets want to use these days. But remember, we're using the inrushing air, the 60 to 80 litres of air that rushes into the bowl to clear the toilet. The water is simply there to clean the bowl round. So we can see that they become very, very environmentally friendly. There's the range of toilets there. There is another point I want to come to for the person that asked that question a little while ago. But here's a little something I like to do. So if we look at compare a system with a vacuum toilet system and a gravity system, and let's look at say a railway station where toilets might flush 10 times an hour. Now 10 times an hour sounds an awful lot, but that is only once every 6 minutes. And if you see the queues to the ladies' toilet, sometimes you'll know that it's probably a lot more than that. And in my example here, I've got 20 toilets flushing at 6 litres a time. And before anyone types in conventional toilets only use 4.5 litres or 3 litres, yeah, that you're probably right. But I find that in most instances where you have dual button, most people just tend to press the button. They don't necessarily look for the right one. So in my example, I'm saying that a gravity toilet is going to use 6 litres. The same example with our vacuum toilet, only using 1.2 litres. So you can see in a 1 hour period that we've saved nearly a cube of water. And if you add that up over a period of time, so 100 days, that's enough water to fill an Olympic-sized swimming pool. Water that would simply just be flushed down the drain. And you can see there from that graphic how many toilets there are, Evac toilets there are fitted in the world, and how many litres or gallons, depending what side of the pond you're on, are being saved each year by the Evac system. Lots and lots of water. Okay, so I kept quiet while that was on, just in case you couldn't hear me. What you saw there actually was an animation of the vacuum toilet, and I would have liked to have talked through it. I'm not sure if you could or couldn't hear me if I did so. But what you had there, you saw was the toilet flushing. There are two valves at the back of the toilet. We'll call our discharge valve and our water valve. Our water valve opens to allow the 1.2 litres of water in. The discharge valve opens, that's where the 60 to 80 litres of air comes in. And somebody's asked, where's that air come from? That just comes from the environment. That comes from the room itself. So 60 to 80 litres of potential foul air is being pulled into the pan, and that's pushing the waste through. And then when the discharge valve closes, the water valve stays open a little longer just to fill the bowl up, so that when you go to use the toilet and you look down the pan, you're seeing water in there to make it look as normal as possible, so you don't see then a dry bowl. Now, going back to the question that somebody asked a few moments ago about the range of toilets. At the moment, there is a couple of toilets available for vacuum, and they come with a floor mounted or a wall mounted option. But what if you want to use another toilet? What if the Evac toilet is not to your taste, or you need a toilet that you really think wants to match other sanitary appliances? Somebody asked a question, I think a little while ago, can you combine a gravity system and a vacuum system? And you can't combine them as such, but I'll give you an example of one building we're about to do for a hotel next year, where it's a 5-story hotel and there's a north and south side of it. And on one particular side, it sits above a Wetherspoons pub. And on the second floor, or the first floor of the hotel, Wetherspoons will not allow this particular hotel to come down and penetrate through into their domain. So they can't put a drainage system in that side. Well, they can if they use a vacuum system. So they're just choosing to use the vacuum system on this particular side of the building, on this particular floor. So about 15% of the building is going to be vacuum. The rest is going to be gravity. So that's how you can combine the system, by taking a portion of it. But they're two very separate systems. And on this particular hotel, the rest of the gravity rooms, which I'll refer to them, are using a particular type of toilet, so the architect's choice. And the architect said, well, if we want to use a vacuum system, I don't want to use the Evac toilet, I want to use my toilets in these other rooms. And at some point in the past, that would have been a problem, wouldn't have been available. It would have been a case of, no, you have to use the vacuum toilet. Until now, because Evac in the last couple of years have developed a product called the Vacuum Convert Frame. And what the Vacuum Convert Frame does is it allows you to fix any toilet to and form it to become a vacuum toilet. So you can take your Duravits, you can take your Ideal Standards, Armsy Shanks, any of these brands of toilet, and now clip them onto the Vacuum Convert Frame, and it turns them into a vacuum toilet. And just like our standard vacuum toilet, again, no electrical connections are needed. It sits onto the frame. It looks like the frame itself is around about the same height and size and width as a concealed system frame. Once again, there is no system. It needs the Cat 5 supply. It will actually use a little more water because it's not been a toilet being designed to use a vacuum. So rather than using 1.2 litres, it will use 2.5. So still good water savings. The payback being, though, you do need that access panel there. Because the mechanism when we use the vacuum toilet is concealed within the bowl of the pan, but the mechanism for the vacuum convert is behind that access panel there. So you do need an access panel. So just looking at some of the questions we've got there. Can you repeat the volume of air that's evacuated in one toilet flush? Between 60 and 80 litres of air. Do we need to provide rodding eyes? Yeah, it's like any drainage system. where you have changes of direction. The pipework is smaller. I'll come on to that in a moment. But yes, change of direction do need to have rotting eyes. Are the hand basins similar to vacuum toilets? No, only the vacuum toilet, or using the toilet, the vacuum convert frame. All other sanitary ware is standard, and I'll tell you why in a moment. So another question there, someone's asked about showers and kitchens. I need to cut, I'll come on to that. Do you need to shut the whole system down to do any modification work? No, again, the system can be divided into sectors, and taking, say, something like King's Cross Station, for example, which is a project we did back in 2012. We've got ladies' toilets, we've got gents' toilets, and we've got retail units. And there are 3 vacuum mains that serve those areas. One to the ladies, one to the gents, one to the retail. So if you want to work on the ladies' toilets, you can go back to our vacuum plant, shut the ladies' toilets off, everything else remains online and unaffected by what you're doing. And shut-off valves can quite easily be put further into the system on risers to actually reduce or increase, should we say, not reduce, increase your flexibility further as you go along. Someone's asked the question, can pipes be buried in the slabs? Yes, they can. And no, you don't need any additional mechanical ventilation to cater for a vacuum system. But like we said, when we look at our toilets, only using 1.2 litres. And let's just look at these points here. Takes in surrounding air and odours, ventilation, and the reduction of airborne mist. This is actually very, very relevant at the moment. There are videos you can see online where people are flushing gravity toilets, and they're putting UV fluid into the toilet and putting it under a black light situation, flushing the toilet and seeing how far the airborne mist travels. And you'll actually see that with a gravity toilet, airborne mist can travel up to around about 2 meters. So each time you flush your toilet, you're getting a cloud of this mist that will travel up to say 6 feet. We've done the same test with vacuum toilets, and because of the 60 to 80 litres of air that's poured into the system, there is no airborne mist. So it makes it not only the flexible alternative or the flexible solution, and it also makes it the water saving solution. It actually makes it a health solution. Now, this pandemic that we're currently in, when we first started, the World Health Organization turned around and said COVID cannot actually be transported through sewage. My colleagues who work in our American office have found several articles now saying where people in apartment blocks have infected their neighbours, and I think it may be something to do with the ventilation system they've got there. But now seems to be proof that sewage can actually be transposed through fecal matter, and having a toilet that repels every single virus and every single piece of bacteria into the actual pan because of the air that it needs to transport waste through does seem an obvious health benefit. Does this have an image on the main sewerage network with less water being used? Well, we're not actually just using the vacuum system. Well, in most instances, we're not just using the vacuum system to collect the toilet water. We'll have the grey water from the buildings often fitted to it as well. We do have some purely black water only systems, and no, it hasn't affected it. It comes back, it's stored in our collection tank for a certain amount of time, depending on the amount of water that's coming back, and then discharged to the sewer. No residential odour in the bathroom at all because of all the air and everything that's poured into the system during the flush. So quick animation here, and I hope you can hear me. you can see the difference between the gravity toilet and the vacuum toilet. Lots of airborne mist on the right-hand side there. Big water savings, perhaps not quite as much as 90% now, as gravity toilets have come down in their use. So, will the system block, and how big is the risk of blockage, is a very good question. The vacuum toilet, the mouth of the bowl is slightly smaller than the pipework it's going to pass through. So the idea is if you're going to get a blockage, and I don't like using this word encourage, but because of the way the vacuum toilet has been built, it encourages that blockage to happen in the bowl, because it's far easier, even though it's unpleasant for somebody, but it's far easier to come and deal with a blockage in a toilet bowl than it is to try to determine where it is in the pipework. So generally, if it passes through the pan, it's on its way back to the through the pipework all the way back to the tank, which is testament to the story I was saying earlier about when we open the tank, we're finding t-shirts and towels and pairs of jeans that have worked their way through the system and are sitting in the tank. So when it comes to other appliances, the question that I asked a while ago, basins, baths, and it doesn't have to be bathroom waste. It doesn't have to be kitchen waste. I'm looking at a project at the moment where somebody has a service tunnel and they've got condensation and they've got sumps, they've got groundwater, and they want to use vacuum to get rid of that waste. I'm working with other people in laboratories. It can be any fluid that you have at all. So don't just think it has to be around about, I've used railway stations as hotels as examples, but don't think it always has to be around standard sanitary waste. So when we drain the waste from any other item, where it be a huge tank full of chemical, whether it be a small wash basin, they will drain by gravity into an item which we call an interface unit. And you'll see one particular one on the screen there. And they come in various shapes and sizes, depending on what it is we're putting into them, flow rate and the type of water, etc. Just like the toilet, they're pneumatically operated again, so no electrical connections needed. And like I said there, we can take these from any sort of standard bathroom fittings. It could be kitchen fixings. And nobody's asked the question yet, which is one I normally get, about grease. How can it handle grease? And my normal response to that is that you wouldn't let raw grease go down a drain because it's illegal, but it often does. And it's the same with a vacuum system. We'll go back and see there'll be a gravity line from a sink. It will go through a grease trap before going into an interface unit like you see on the screen. And you'll see the grease trap. It's apparent by looking at the screws on the top that it hasn't been opened for weeks, months, years. So in answer, before anyone comes up with the question, it does handle grease pretty well. And it doesn't necessarily mean that you have one particular item to one particular interface unit. So the example you can see on the screen there was taken from a bathroom at a public cinema, and you can see there are 6 wash basins in the picture there, and they all drain down into one interface unit. So you can almost think of it like you were sizing it for a pump, only this pump doesn't have, this pump's an interface unit, and it doesn't have any electrics, it doesn't have all the mechanical parts that can go wrong with it. So it's a far simpler solution. And when it fills to a certain level, it discharges automatically, and just like the toilet flushing, then puts that water into the system. So someone's just asked a question about can it be used with a wastewater treatment plant? And yes, it can. So a good example of this was a project we did at Stonehenge and the visitor centre, which was opened, I think it was around about 2012. Wanted to use a vacuum system there because there was no way they could dig into the floor in that area. It's the biggest archaeological site in the UK. You dig down there, you find anything, and the place is shut down while the time team guys come in. So we were allowed a 1 metre trench to run our drain pipe in to what they called their ancillary building. So we had a vacuum system inside the visitor centre. I don't know if any of you have ever been and visited it, and maybe even used the toilets there, not realised. But that then, the waste is taken at high level to the evac unit, which is located in the corner of that building, and then transferred via the pump on the vacuum plant up to the ancillary building where the water treatment unit is sited. The water is treated to a degree where it's almost potable again. It's as clean as you can get it. Some of the water then travels back around and circulates and flushes the toilets again, so it's recycled. And the rest of it was meant to be quite simply dumped on the land. But the Environment Agency said that there was no way they were putting that water on the land. There's an aquifer under there that feeds the water supply to Salisbury. Someone did come up with a counter argument that there are 1,000 sheep urinating on that land, but no, it wasn't good enough. So this almost clean water has to be removed by vehicle. But so yes, the answer to the question is it can be integrated into a wastewater system. And like I said there, we can take water from any style of environment, whether it be factory, hospital, office block, anything you want to do. We'll have an interface unit. Supermarkets, we do a lot of work in the supermarket industry because the fridge cabinets all create a certain amount of condense. So a very big area for us to work in. Now, when the waste has worked its way through the pipework, it comes back to our vacuum plant. This is the only part of a vacuum system that needs any electrical power. It sits on the lowest floor we're draining or below. So if we were draining first, second and third floor in a building, the plant can sit on the first floor or the ground or the basement, but it can't go up higher than that because of the maximum lifts that are achievable with vacuum. And like the interface unit, it can take and handle different types of water. Now, the types of plant we use consist of the collection tank, the vacuum pumps, the discharge pumps, and the control panel. So first of all, we have our vacuum pumps. Now, to fall in line with the European standard, there are 2 vacuum pumps, and the vacuum pumps are sized. And the question there, how do we determine the size of the vacuum collection unit? That's something we offer you as a service by taking the information of the amount of water flow that you will give. It's a little more complicated than that, but I won't go into that too much at this stage. But we have to comply with the European standards, 2 vacuum pumps, and 1 vacuum pump is enough to do the project. But we have a second one there to give you that complete 100% redundancy. They'll be sized appropriate to the amount of water that we're drawing. These are what we call offline vacuum pumps, and what that means is that none of the sewage that we collect actually passes through these pumps. So that reduces the chances of the towels and the debris and all the bits and pieces that get put down a vacuum toilet system from getting into that pump and causing a blockage. And secondly, as we're only putting air through the pump, it actually makes it use less energy than if we were driving water through the pump. So that puts the vacuum into that tank and all of the associated pipework. When the tank reaches a certain level, then we have discharge pumps. Again, standby and duty discharge pumps, which gives us the potential to position our vacuum plant wherever we want in the building in relation to the sewer connection, or in some cases the treatment plant. We don't have to locate it right next to the drain. We can put it because we have these powerful pumps. How do we determine the size of the collection unit? Someone's just asked. Once again, that's something that we put together based on the information that you've given us. And maximum size of the system, there isn't a maximum size because what happens is if you get a system like a hotel project we're doing, It's a subterranean hotel in London. There's 245 bedrooms on it, and we have to get 2 vacuum plants and put them together to form a double unit. So then that gives us the complete redundancy to be able to deal with 245 bedrooms and showers and wash basins. So the system can be as large as you need it to be. We'll just put the appropriate and size of equipment there to be able to handle that. And then we also have our collection tank. Now, for us, the collection tank we see is a pretty critical part of the system. And we only ever fill the tank up to the halfway point. So when the water reaches the halfway point in the tank, that then initiates the discharge pump and pumps off to the sewer connection, wherever that may be. Now, why do we only fill up to halfway, and why do I think the tank is important? That's because if the half of my tank is full of water, the top half of my tank is full of vacuum, and that is my energy supply. So if we were running the system without a tank and we had a pump only, and maybe we had 5 or 6 toilets that were under constant busy use, the first toilet needed to be flushed, and if the second toilet needed to be flushed, the pump has then got to run and make vacuum and get enough vacuum to operate that second toilet. And if in the meantime the first toilet, or the one nearest the pump, gets flushed again, that will then take priority because the vacuum's at its strongest point. The 5th toilet in the line has to wait for everyone to be quietened down before it can even work. So that tank absorbs that impact use. And like we said with the toilet, we don't want people to look at this and think I'm in a vacuum system. They just look at it and say it's a toilet, or they don't think about it at all. So the last thing we need is any delay in flushing or sinks filling up with water when people pull the plug out, and then water suddenly going away when there's enough vacuum. The capacity of vacuum in that tank always lets us absorb any impact use and keep the system running as fluid as possible. So to back up the questions that have been asked, the size of the vacuum tank, the discharge pumps and the vacuum pumps are dimensioned by ourselves here as our design team. We would ask you for a certain amount of information on flow rates and use, and then we have a design tool that we feed all that information into, and then that puts out the size of the vacuum pumps, the tanks, and all of the pipe work that we need to use. It comes with its own, it comes as a package piece of kit like we see there, with the control panel on the front, which we can connect into the client's BMS system if need be. I hope you can hear me while I'm showing this. So with water flowing into the tank from the 3 different lines, the water gets to the halfway point, and then the discharge pump cuts in and pumps it away. And one of the things that we can see there is that the discharge pump cuts in, but whilst the discharge pump cuts in, that doesn't mean that we can't still create vacuum, and it doesn't mean we can't flush toilets when that's happening. The whole system is automatic, and again, we'll get uninterrupted use. So let's have a look at a few benefits of vacuum systems. I think in this first line here with the health and hygiene, I covered that a few moments ago when I was talking about the airborne mist. That is now becoming very important because of the world we're currently living in. Before, I always used to say that the most important part there was the flexibility. The fact that you can put drains anywhere you want. You don't have to. If you remember right back at the beginning when I showed you that building with the stacks, you're not having to rely on where those stacks are. You can literally put things where you want. We can route around obstacles because of the flexibility. And small bore piping. Someone's just asked a question about what size pipe do we use. Our risers from toilets and from interface units for sinks, just 50 millimeters. Our high level pipe work will be 63 or 75 millimeters, depending what material we're using. Most projects are used with a PVCU solvent weld pipe, and it's not UPVC, it's PVCU. So it's thick walled, pressure rated, 16 bar positive pressure, so PN16 pipe. There are some projects that won't allow the use of plastic, and in those projects, in the main, we use stainless steel. The push fit stainless steel product is what's often used. So nothing like the 100mm or 150mm pipes that you're used to. So it's like the pumps are in contact with air. Does it mean there's risk of cavitation? No, because what happens is the pumps pull air from the system and they're on a pressure gauge. And when I spoke earlier about the maximum pressure being -1 bar, we don't work at that level. We tend to work between anything between -0.45 to -0.7 of a bar, depending on how high we need to lift. I.e., if we need a 6-meter lift, we need to work at -0.6 of a bar. And what happens is the pumps will run and create a vacuum, and a pressure switch will say, right, you've hit the vacuum level that we need to, so the pumps switch off, and that air is just simply blown out of a vent pipe to atmosphere. And then as the system starts to get used and the air is being pulled into the system, it will diminish the vacuum that's being made. So when the pump reaches another set level, the pump will then start in and run again. So we don't get constant running of the pumps. The pumps run on demand. You go to a system in a hotel and you're there at 7 o'clock in the morning in the peak hour, and the systems will be running very hard and working very hard. You go there mid-afternoon when nobody's in the rooms, it'll be sitting there idle, not doing too much. So a few more benefits here. Construction insulation, no vents required. I mean, I did just say there the air goes out of vent. That's the only vent you need from the tank. You don't need any venting from the toilet system. It's a complete enclosed system. Where we're running out of time, so I'm speeding this up a bit. The ceiling penetrations. A good example of that, we did a project called the Great Eastern Hotel, and it was a Victorian building which had only communal bathrooms at the end of corridors. And when they relaunched it in the 90s to get 5-star status, and what's demanded of today is that all rooms had to be en suite. So you can imagine every room would have needed a 100mm hole drilled in the floor to accommodate the bath waste, and close enough that the basin can share it, if not one for the basin. Sorry, 100mm for the toilet, and then 50mm holes for baths and basins. Now, there are 32 rooms on a floor, so that could mean 64 holes have to be drilled. By using the vacuum system, everything is taken to high level. That pipe runs at high level in the corridor with the other rooms coming in and joining onto it, and then drops down 2 holes in the riser pipe at the end. So that's when we get the benefit from the construction side of things that can be saved when it comes to using a vacuum system. Does the vented air smell? Yes, that does smell. That is foul air. So it has to go on to has to be pumped to atmosphere, just like any other vent pipe would. Someone's asked about toilets on upper floors contaminating lower floors. Can't happen in a vacuum system. Like I said earlier, if you get a leak in a vacuum pipework, it means air leaking in, not water leaking out. And if you do get that situation where air leaks in, and what will happen is then that will cause the pumps to run, and if the pumps are running, that will start to bring up alarms to tell you, and then you can determine whereabouts in the building it is. Just very quickly on this one, because I realised that we're getting towards the end of the hour. My company also offer a vacuum food waste system, and we've just put our first vacuum food waste system into a tall building in London, 22 Bishopsgate, which is a 63-storey building, and all of the restaurants are going to be on the upper floors, and the client didn't want food waste being travelling down through the building and leaving a horrible sticky mess, so they're installing a vacuum food waste system. I just pull that. That all does look very industrial, I must admit, but what you can think of is that will actually be embroiled into a stainless steel counter. So you won't have what looks like a food toilet sitting there necessarily, but in effect, that's what it is. You load all your food waste into it. When it reaches a certain level, you press a button, and then that food is macerated, added some water, and again, just a 50mm pipe will take that down to a collection tank at low level. And the one that we're doing at 22 Bishopsgate, all of that waste will be collected and be taken away to be reused and formed as biofuels. And it's around about £80 a cube to take waste to landfill, and about a tenth of the price if you're taking it to form biofuels. So there's a good payback for the customer. So just wrapping up now, I've alluded to it already in the conversation that as part of our service, we size all of the system for you. So you don't have to think, oh, I would like to use a vacuum system, but I'm a little bit worried I might not be able to design it properly or might come up with some problems. I will ask you certain types of information, and I will then be able to put together the necessary equipment for you. And even if you think I've got a project and, well, you know, I'll have a look at potentially using vacuum on this one, feel free, come ask me. I'll give you a budget quote. It doesn't cost anything. And it's just something that if it doesn't happen vacuum wise, you've got in the back of your mind for future projects. And then during installation, we provide project management. We run an installer scheme, so the main company will get competitive quotes from our registered installers, and then at the end of the project, we go to site and we do a commissioning. So we're commissioning our equipment and our installers' installation, making sure everything's working fine. And then when the project's finished and all the builders and everyone's gone home, we're still there working with the client, offering maintenance. We have different service partners that can offer sort of 24/7 support to the projects, and we have a large range of spare parts here in the UK. So if someone needs a spare part, we can get it to them, worst case next day if they're within range, same day if necessary, which is everything that we offer. I have some examples of projects I've done these. I think because we've run out of time, I'm just going to show you these and rather than explain everything. But Heathrow T5 was a big stellar project for us around about the same time as we did St Pancras. And all these projects were, I can't use gravity because, and then they had their own reasons. This one, for example, had an underground station underneath it. This particular place was built in the Westfield Shopping Centre on top of Marks and Spencer's. And Marks and Spencer's couldn't, sorry, someone's just asked for a project in the Caribbean. It just put me off a little bit there. But this one was put above the Marks and Spencer's, and Marks and Spencer's didn't want their waste coming down through their domain. So vacuum system was able to deal with that. This particular place, because it's rooms of bars and restaurants and a TV studio, and they decided to put a hotel on the 3rd floor, and then it was acoustically treated, so you couldn't start punching holes through it. So by using vacuum, everything was lifted to high level and taken down acoustically treated risers. And then finally, my food waste system at the 22 Bishopsgate. So that sort of pretty much concludes the, I'll just stop that in case it drowns me out. That sort of concludes the presentation. I've seen some questions pop up, and I've hoped I've been able to attempt to answer most of them as we've gone through. Malcolm has my email address. You can get that from him should you need any more information. If anybody wants the presentation sent through to them, I can do that on WeTransfer, so you can see the animations. And like finally, if you have a project, you have something you think you'd like to investigate vacuum, it doesn't cost anything, it's non-committal, give me a call, we'll have a chat and I'll put some details forward for you. Okay, thanks. Yeah. Thanks very much for coming, especially in such grand numbers. Thank you.